Salam and welcome everyone. So today we're going to be working on the question on the screen that says, write the wave function for a particle of mass 2.0 grams traveling to the left with kinetic energy 20 joules. So the first thing you have to do is to read the question, write out the parameters. We're told to write the wave function of a particle. So basically, we don't know what the wave function is, and that is basically what we're told to solve for a particle of mass 2.0 grams. So we have the mass of the particle, which is 2.0 grams, and we're told that it was traveling to the left with kinetic energy 20 joules. So the kinetic energy E sub k is also 20 joules. So the first thing I want you guys to notice is this. This is a question from the Atkins Physical Chemistry 11th edition textbook, particularly from chapter 7, and the topic deals with translational motion. So, in order for us to solve this, let us make sure we understand the keywords here. We've been told the wave function of a particle and it's traveling to the left. In this particular chapter, we are taught about free motion in one dimension. One dimension meaning just in this case, we can see that we're dealing with just one dimension, one direction, whatever you want to call it. So, just as I've said that this is in chapter 7D, there is a formula called the formula for free motion in one dimension. And it says the wave function of x, again, one dimension, so just x variable, is equal to a e raised to the power of ikx plus b e raised to the power of negative ikx, where this first part, a e raised to the power of ikx, is just simply the linear momentum k h slash or h bar. So basically, linear momentum is equal to positive kh bar, and then the right side is just saying the linear momentum is equal to negative kh slash or kh bar. I wanted to quickly mention this to you guys because whenever you see a question like this, you're going to be wondering, how do I solve this? Well, we're asked to solve for the wave function. We should write out the wave function for a particle traveling to the left. Now, this is going to go to zero because our particle is traveling to the left. Hence, the sign of the linear momentum is going to be negative. So we're going to rewrite this as the wave function is supposed to be b e raised to the power of negative ikx, and we can simply ignore the b this time and just say the wave function is going to be in terms of e raised to the power of negative ikx. So this is what we're supposed to get our answer in form of. So when they tell us to write the wave function of a particle traveling to the left is always denoting the negative value for linear momentum, while the right traveling of the particle, it is denoting or will denote the positive um, value of linear momentum. So basically, left is negative kh for negative value of linear momentum, and then positive would indicate right for the positive value of linear momentum. So that is basically what is going on here. So, anyways, so this one now, the wave function has to be negative ikx because we're dealing with a particle moving in the left direction. Now you're going to be wondering, well, I is just imaginary, denotes the fact that it's imaginary number. X is the variable, so we actually don't know what the value for k is. So basically, what this is question is actually requiring us to do is that we're going to have to first of all determine the value of k, which is the unknown, using the parameters that we've been given. We've been given the mass and the kinetic energy. So the mass again is 2.0 grams, which we can rewrite to be 2.0 times 10 to the power of negative 3 kilograms. And then, of course, the kinetic energy E sub k is just simply 20 joules. Now, I also wanted to mention this to you. For those of you who don't know, when you're dealing with, again, a particle that is allowed to freely move, in this case, a free particle, just moving on its own, there is a formula for kinetic energy. It's not the usual E is equal to half mv squared that we know. There's actually a completely different formula that we're going to use, and the formula is just simply E sub k. So the kinetic energy is equal to k squared times h bar squared divided by 2m. And of course, we know that the m is the mass, the h bar is just the Planck's constant bar, or the reduced Planck's constant. And the reduced Planck's constant has the value h bar is equal to 1.0546 times 10 raised to the power of negative 34 joules second. So this is h bar. By the way, both of you, by the way, those of you who don't know what h bar is or h slash is, h bar is just simply the Planck's constant divided by 2 pi. So it's also a constant value. So that is what h bar is. Yeah, so that is it. And we are to determine what k is. We're also being given the E sub k, which is the kinetic energy, which we know to be 20 joules. And then, of course, the mass to be 2.0 times 10 raised to the power of negative 3 kilograms. So we're going to rewrite this equation in terms of k. So when we rewrite this equation in terms of k, we end up with 2 ek. So I'm just doing the calculations. 2 ekm, or 2 e sub km, is equal to k squared h bar squared. And of course, k squared is just simply going to be 2 e sub km divided by h bar squared. And so k is equal to the square root of 2 e sub k m divided by h bar squared. So this is basically the formula in terms of k. So of course, we can now simply substitute. So we have k is equal to the square root 2 times E sub k. E sub k, we know that to be 20 joules. So 2 times 20 joules times the mass of what we're given, which is just simply 2.0 times 10 raised to the power of negative 3 kilograms. So 2.0 times 10 raised to the power of negative 3 kilograms divided by h bar squared, which is just simply 1.0546 times 10 raised to the power of negative 34 joule seconds all squared. So 1.0546 times 10 raised to the power of negative 34 joules seconds all squared. Now you're going to be wondering, well, we've successfully done all of this. So all we have to do is cancel out the units, do the multiplication, and everything is going to be all right. Now, we cannot go on to do this just yet for no other reason except that we have to remember that we have our units here in kilograms, our units here in seconds, our units here in joules, our units here in joules. We cannot cancel out those joules even if we squared it, because we're still going to have 1 joules left, 1 unit of joule left in the denominator. And we know that for the value of k, we want our answer. So by the way, the unit for k is usually 1 over meters, okay? 1 over meters is what we want the units to be. And in this case, there's no other way we're going to be able to get 1 over meters, because all our units, we don't have anything in meters. So we now have to remember that this unit of joules that we have is the same thing as kilogram meters squared per second squared, right? Kilogram meters squared per second squared. What this is telling you is that the unit for joules, which is kilogram meter square per second square, is the joules itself is the SI unit of energy. And if you remember, energy is the same thing as force times distance. If you remember the formula for work done, a form of energy is force times distance. And the formula for force, when we break it down, is just simply mass times acceleration times distance, if we want to determine the fundamental information to calculate the energy. So basically, force is mass times acceleration, and energy is just force times distance. Hence, energy is mass times acceleration times distance. And if you look at each one of them, the unit for mass is kilograms. The unit for what they call it, the unit for acceleration is meter per second squared, and the unit for distance is just simply meters. So that is how you get kilogram meters squared per second squared. So we're going to substitute kilogram meters squared per second squared for in every point that we have joules in order for us to continue further in our calculation. So you have k is now equal to the square root 2 times 20 kilogram meters squared per second squared multiplied by 2.0 times 10 raised to the power of negative 3 kilograms divided by 1.0546 times 10 raised to the power of negative 34, and then joules seconds all squared. We can rewrite this to simply be 1.1122 times 10 raised to the power of negative 68. And then, of course, this is kilogram meter squared per second squared. Um, and then you have seconds here. So let us first of all do the squared of the numerical value. So just this part. And then we can take the units one by one. So it's the same thing as us squaring kilogram meter squared per second squared. So let me just write that down. It'll just be kilogram meters squared per second squared. Let's not forget that we still have this seconds here because the h bar units is joules seconds, and just the joules is kilogram meter squared per second squared. So we have to multiply, okay, by the second here, and all of this here all squared. So I like to break down information like this because it's very easy for you to lose it if you're not careful. So k ends up becoming the square root of 2 times 20 times 2.0 times 10 to the power of negative 3 times kilogram meter squared per second squared times kilogram will end up giving you 8.0, okay, times 10 raised to the power of negative 2 kilograms squared. So this kilogram here and this kilogram here will give you kilogram squared. Then you have meter squared and you have second squared. So that will be kilogram meter squared per second squared divided by 1.1122 times 10 raised to the power of negative 68. And then, yeah, so 1.1122 times 10 raised to the power of negative 68. And then, of course, you have kilogram squared here. Meter squared is just meter raised to the power of 4. And then, of course, cancel out the seconds here. Cancel out the seconds here. Seconds are in the denominator will end up just giving you seconds squared. So yeah, that's basically it. So let me rewrite this. So now that we have broken all of the information down and we've gotten our units correctly, we can just simply cancel out. We can cancel out kilogram squared here and then kilogram squared here. We can cancel out meter squared here and we can cancel out meter raised to the power of 4 to become meter squared. Cancel out the denominator here and the denominator here. So yeah, that's how you do it. So k ends up becoming the square root 7.192951 times 10 raised to the power of 66, okay, divided by meter squared. So that is basically the work so far. So of course we are going to do the square root of this value. When we do the square root of this value, we end up getting 2.681978 times 10 raised to the power of 33 divided by, then you have, of course, meter square. Square root of meter square is just meters. So we have our answer to just simply be k is equal to 2.681978 times 10 raised to the power of 33 meter raised to the power of 1. But our work is still not done because we're scientists and we're supposed to put our work in the proper number of significant figures. And to put our work in the proper number of significant figures, we have to go back to our question to determine the number of sig figs that this is supposed to take. So going back to our question, we see that we have 2.0 grams and 20 joules. We can see both of them are in two sig figs, which makes our final answer to be in two significant figures. So k is equals to 2.7 times 10 raised to the power of 33 meter raised to the power of 1. So that is basically that's basically the value for k. So the wave function is just simply going to be e raised to the power of negative I k x, where I is the imaginary number, k is just 2.7 times 10 raised to the power of 33 meter raised to the power of negative 1, and then there's x. So the wave function is simply going to be, wave function of x is just simply e raised to the power of negative I 2.7 times 10 raised to the power of 33 x. So this is basically the answer to this question. Remember what the question actually asks us to do? In case you're forgotten, let me quickly remind you. They told us to write the wave function of a particle of mass 2.0 grams traveling to the left with kinetic energy 20 joules. So basically, what they wanted us to do is to determine the wave function. I'm just saying it's just because I don't want a situation where people would solve for k and they think that's the final answer. You have to remember at the beginning, I explained the wave function, the fact that the wave function, when you ignore b, is just going to equal e raised to the power of ikx. But we don't have the value for k, so we can't really do anything with it. So we used our understanding of the kinetic energy and all the other information we were given to be able to determine k using the equation e sub k is equal to k square h bar square divided by 2m. When we did that, we rewrote the equation in terms of k, and we ended up with k is equal to the square root to e sub k m divided by h bar squared. We did all of this information and determined the value for k, and we have to substitute that value for k in order for us to have the proper wave function. So, and of course, the wave function equals e raised to the power of negative because of, from what we were told in the question, the wave function, the particle, right, is going towards the left. So yeah, that's basically it. So don't forget, anytime you determine k, in case they give you another question in your exams or your quizzes, do not forget to substitute the value for k the way it's supposed to be. So yeah, that's basically it. This is the answer. So if you have any questions, suggestions, or concerns, make sure you put it in the comment section. I'm here to help you. My goal for this channel is for you to be a great hub for students who are trying to succeed in their STEM courses. And if you have any personal questions from your classes that you would want me to work on, please email me at shahabitutoring@gmail.com. But if you have any suggestions or concerns, put it in the comment section. I also wanted to mention, very importantly, that if you're a student who is struggling or who is trying to succeed in all your STEM related courses, whether you're in middle school, high school, or college, I'm the tutor for you. I help students succeed in all their STEM related courses in order for them to thrive in academia. So if you would need my tutoring and mentorship services and you love the way I relay this information to you, make sure you email me at shahabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.